Good evening. How is everybody? Good. No, good. Freezing to death. Yep, it's pretty cold. Loving it. Welcome. Thank you for coming this evening. It's been a busy last couple of months for me, so hopefully it's been busy for you guys as well and getting stuff done. Put up a thing to see what have people been doing over the last kind of user groups. Analyze an account security incident. I hope that wasn't a bad one.
When are they good?
When are they good? That's a fair point. Reviewed billing. Yeah, that sounds fun. Retrieved an event from SQS. You personally, or? It's cool. All right. Well, welcome. Thank you for coming. I feel like the months go very quick, and we were only just standing here before. Played Deadpool on EC2 using Nice TV. Some people got too much time. This will come up later, so we'll be able to keep seeing what people come up and going on. So welcome. If you don't know where you are, you're at the Brisbane User Group. And we've got some great speakers tonight and a last-minute swap on the What's New from AWS. So thank you for the last minute on that. But to get us started, I begin tonight by acknowledging the traditional custodians of the land on which we gather today and pay my respects to the elders past and present. I extend that respect to Aboriginal and Torres Strait Islanders people here today. Cool. If you don't know who I am, you haven't been here before. My name's Ryan. I'm a SA at IDEA 11, AWS ambassador, AWS community builder. I've helped run this thing as well. I'm sure there's some other things I can put on there too. Today we have Neil helping us out with the What's New in AWS. Maxime's here to talk to us about the global data platform. And then we have Michael talking about Rust versus Python. I think that one's going to be fun. Cool. So we'll get started. Pizza will be on its way. I hope everyone has a drink. And we'll kick off with Neil.
Thanks for coming, everyone. As you might have, he said, I'm a rope-in. Sorry? Ryan, yeah. I'm a last-minute rope-in, so I got these slides about 2 hours ago. We'll start at the beginning. No, further. So I'm Neil Gladwin, Senior Solution Architect at AWS, and just to begin, we've got some stats. So 28 days since the last user group, 64 new features and announcements since then, and we've got 15 minutes, and because I'll just be reading from the slide deck, I think I'll get it under 15. So compute, we announced the Graviton 4 processors at reInvent last year, and now they're GA with the R8G instances. These are larger memory instances, so good for in-memory databases, analytics, etc. And of course, they're built on the Nitro system for enhanced performance, and 3 times larger than the R7G. In the security, can you hear me without it? No. Yeah, cool. Language agnostic HTTP service that you can install and read the secret manager, read secrets from the secret manager, cache them in memory as well. This is great for standardization of systems to have a single source of truth for that. Language agnostic. So there's details about that on that link below. The Security Hub has 24 new security controls, so it's a total of 418, included for extra controls for Amazon Inspector, Data Firehose, Guard Duty, and DynamoDB. So for DevOps, the Lambda introduced advanced logging control, so you can capture logs from Lambda in JSON structured format without having to bring your own libraries. Makes it a bit easier to build those things. So also Amazon ECR now emits Eventbridge events when replicating ECR images across region. Allows you to know once replicated images are available for use in the destination registry. So if you've got a global infrastructure for applications, notifying when that ECR image is available will help automate that. Cloud Shell now supports Amazon VPC, so that allows you to launch an environment within a VPC and get native network access to other resources within that. Prevents you from making bad network design to build around that, simplifies that process. EKS introduced cluster creation flexibility for networking add-ons. So you can create Kubernetes clusters without the default networking add-ons. Just out of curiosity, how many people are on Kubernetes in AWS here? Not too many. Less than I thought. Enables you to easily open source or install open source or third-party alternative add-ons and self-managed default networking. Amazon ECS now enforces software version consistency for containerized applications. So when customers deploy long-running applications such as HTTP-based microservices as Amazon ECS services, are often using container images tags to configure these services. Although container images are immutable, image tags aren't by default, and there is no standard mechanism to prevent versions from being unintentionally deployed when you configure a containerized application using image tags. To prevent these inconsistencies, Amazon ECS now resolves container image tags to prevent to the image digest when you deploy an update to Amazon ECS. Storage, data, and analytics. So next-gen Amazon FSx for NetApp on-tap file system. Late in April, a blog post quickly gained the attention of the AWS community. A customer had a bucket named XYZ. If you remember this, who knows of this event? Only a few as well. So if someone deployed that tool without changing the default config, they would be attempting to access the other customer's buckets. They couldn't get in, but this computer was getting charged for each unsuccessful attempt to put objects. So there was a large amount of charges to this customer's account because...
You got the wrong slide?
Oh, sorry, reading that one. No. Next slide, sorry. Yeah. I actually know of the event. I'm just reading some of the notes though. So yeah. So there was some changes made around the billing process with that event. And yeah, I don't know why those notes are associated to that FSx for NTAP. Anyway, highly scalable, enhanced flexibility compared to previous generation file systems. We'll move on. That must have been a copy and paste from another slide, I swear. Yeah. That happened last month, didn't it? Yeah. Thanks, Mark. Amazon Data Zone introduces fine-grained access control, enables granular access control over your data at row-level columns. Data owners can restrict access specific records of data instead of granting access to the entire data set. Data Zone introduces API-driven, open lineage, compatible data lineage virtualization. That rolls off the tongue. Capture, store, and...
Visualization.
Sorry?
Virtualization or visualization?
Visualization. Yeah. I was looking for another virtualization in that visualization. Anyway, capture, store, and visualize lineage of data movement and transformations of data assets on Amazon Data Zone. Glue Studio now offers a no-code data preparation authoring experience. Data preparation authoring in AWS Glue Studio Visual ETL is now generally available. And everything tastes better with AI and ML.
It's the UMSG.
Yeah. I call it deep fried. Everything's better deep fried. Everything's better with Gen AI. Knowledge bases for Amazon Bedrock now supports additional connectors in preview. In addition to Amazon S3, you can now connect your web domains, Confluence, Salesforce, SharePoint as a data source to your RAG applications. This makes it really easy to deploy business applications for internal documents without much effort. Guardrails for Amazon Bedrock can now detect hallucinations and safeguard apps built using custom or third-party foundational models. So blocks as much as 85% or more harmful content. Oh, sorry. As 85% more. Filters over 75% hallucinated responses from RAG and summarization workloads. And agents for Amazon Bedrock now supports memory retention and code interpretation in preview. So agents can now retain a summary of their conversations with each user to help continue the responses through your session, and agents can now dynamically generate and run code snippets within a secure sandbox environment, which is actually really cool. You can run a little bit of code within that sandbox environment. Q for developer. With private code bases, you can now receive even more relevant code recommendations based on your organization's internal libraries, APIs, etc. And Amazon Q Apps is now generally available. And the public preview of AWS App Studio. App Studio is a generative artificial intelligence powered service that uses natural language to create enterprise-grade applications in minutes without requiring software development skills. Has anyone used Party Rock? Yeah. Party Rock, if you just Google it, you can create apps within that are based on Gen AI, and this allows you to do it to the next level. And this is a process of building an application created by Mark. There you go. One of the essays in our group created this for a legal firm around generating contracts. So snippets of a contract to help build a larger contract based on all their internal learnings of their previous contracts. Amazon Q Developer, now generally available in Visual Studio IDE, now available also in SageMaker Studio. Chatting about your AWS resources is now generally available, and Q Developer Chat now has IDE workspace context awareness. Amazon Q Business now provides responses that are personalized to users. Q receives employee profile information from your organization's identity provider that that you have connected to IAM Identity Center. Q uses information such as employee's location, department, and role to improve the relevant response. Has anyone launched Q for Business outside of the US? Interesting. Sorry. When you have Identity Center outside of the US, which is actually my question, sorry. Yeah. There's workarounds, and just talk to your SA and they'll be able to help you launch it. For the regions, the Sydney region has launched Elasticache M7G and R7G. An RDS data API for Aurora PostgreSQL is now available in 10 additional AWS regions. The Melbourne region, and if you're launching applications in Melbourne, there's definitely a lot of incentives to do that now, so talk to your account manager team. There's a bunch of credits available, but API Gateway WebSockets is now available in 7 additional AWS regions. RDS Snapshot Export to S3 is now available in 8 additional regions. And MWAA is now available in 9 additional regions. Yeah, I don't know. I've never actually heard of that one. I'll find out. Ask me after. Airflow? Oh, okay. Yeah, I know Airflow.
Manage something
I'll
Airflow.
ask my friend.
Yeah. You're using Claude for that, aren't you? Not the competitor. Thank you very much. I'll pass you back. I've forgotten your name again. Ryan.
There we go. All right. Hello, everyone. Good evening. My name is Maxime. I'm here from TechConnect, and like half of the company is here to support me. It's very cute. So if anyone starts yelling, they probably know me, but it's okay if you want to yell too. I'm here to talk about the Global Data Platform today. It's something that my team has been working on for over 2 years. Like, it started before I think I was working in the team. And a lot of the big brains behind it are here tonight, so ask them the hard questions, please. A little bit context around the Global Data Platform is that we have had the luck to work with a really cool client that enables us to try out a lot of technologies and push a lot of ideas, and it's been really fantastic to work with it. And so they came up with the idea of needing to have a simple location of where data can be streamed into and where it can be easily distributed to multiple teams, because they've got multiple teams and projects working in the organization, and everyone's working on data but analyzing it differently. So it's a little bit of a coordination issue, I'd say. So the idea was to create a centralized location for data to be sent to and distributed from, nice and simple. But working with data, we also needed to make sure that we're maintaining our integrity of the data so it's not dirty, and we make sure it's guaranteed delivery, so we don't want to lose any data, obviously. We also want to make sure that we've got some ability to control and change what data is accessible, so not allow everyone to access absolutely all the data, introduce some filtering capabilities and such. And the original use case was that they wanted to be able to consume Kafka feeds from on-premise data centers, have this data available and accessible so that different teams could consume from it. But the original use case was for that data to end up in Snowflake. So we had this use case, but on top of that, we also had the use case of designing for the unknown. So knowing that there were so many use cases that we didn't know about, so we needed to make sure that when we built the application, that it was going to be suitable for whatever was thrown our way. So I'll just take you through the simple concepts so far. So we've got the maker, which is just a producer to the platform. That's the terminology. We've also got the concept of a tenant, which just groups makers together. So if a team produces different types of data, at least they can be identified as belonging to one tenant. We've got the global data platform, which is what the main talk is about, and that's where all of the incoming data is going to be managed, prepared, and to be consumed, and then eventually distributed to different takers. The takers determine how they want to consume the data and what they want to receive as well. So that filtering concept coming in again. Now, I'll just quickly give you a little bit of a glimpse as to the architecture that I'll go through today. It's a lot. I'm not just going to keep this up, but if the beer hasn't already, let this tantalize your taste buds. So stripping all of this back, we'll go back to the original Snowflake use case. And that is where we want to make sure that the users, so the makers, or teams really, are able to send their data into one central location, and we're going to call that component the stream management. And then into that, we're going to send it through the architecture that allows it to be sent off to Snowflake. We'll call that the regular taker path. Now, for stream management, as you might have suggested, as the name says, we decided to go with Kinesis Streams. Each maker or producer of the platform would be sending their own data to a Kinesis stream. For the regular taker, something that paired wonderfully with the Kinesis stream is the Firehose. And amazingly, the Firehose is an integration with Snowflake directly. So with a little bit of collaboration with Snowflake and the credentials, that data, once it lands in the Firehose delivery stream, it can go off to Snowflake immediately. But of course, we've got a little bit of add-ons here, like the transformer function that's hooked up directly to the Firehose. So it allows us to just perform any additional filtering or transforming functions if we need on the data. And then that returns it to the Firehose delivery system, and then it goes to Snowflake. You'll notice that I've got maximum retries over 2 hours. If something goes wrong, it doesn't just retry that same thing for 2 hours. If it is something that can be retried, like the system is down or Snowflake isn't responding, it will retry it. If it's saying that your data is absolutely not compatible or you've given me the wrong Snowflake credentials, it's not going to retry it, it sends it off to the failed bucket. And because we don't want to lose any data, we've got the guaranteed delivery, we've got alarms on any objects that land in that bucket for us to be alerted and for us to review it, because we don't ultimately know what's happened. Perhaps the maker has altered the data that has come through, and we just need to be able to communicate that change. And of course, we've got PagerDuty hooked up so that we can wake up when we're sleeping. So we have this simple path, which is great. But as I mentioned, there are additional use cases. So one of the other use case that we were introduced was, OK, this is nice, but we want to be able to send this data to other AWS applications, and we also want to make it faster. So now we've got the fast taker. Once again, if this fast taker was to consume from the same producer or maker, we have enhanced fan-out consumers, which can be enabled for the Kinesis stream, which is great. So it doesn't affect their throughput because it's dedicated throughput. It means the consumers don't need to fight for who's going to be getting great latency or what data or anything like that. The other thing I'd like to point out is that we've got a role at the end. We decided not to send the data to the applications and instead allow them to consume from the global data platform. So we just wanted to make sure that with guaranteed delivery, we're guaranteeing, I suppose, the availability for them to consume the data. That means that we don't need to deal with any of their application issues like throughput exceptions or their own application updates. We're just making sure that it's always available for them. And we're just allowing their AWS role permission to consume from an SQS queue. So some of the requirements for a fast taker is obviously low latency, similar to the regular taker, the ability to filter, error handling, guaranteed delivery, and of course, easy to maintain and update, which was actually key for what architecture we went for here. because our first attempt at this was a Lambda function, which makes a lot of sense. It can process, throw in a Python script there. But at the end of the day, it was a lot of maintenance. When you're working for such low latency, there's a lot more overhead of actually handling the script than initially we thought. And so that's why we decided to go with Eventbridge pipes. The beauty of this is that it's AWS managed service. So it's a lot simpler to use and maintain. It offers flexibility of transformation, so we can still have that enrichment function attached to the Eventbridge pipe. It's got multiple different destinations. Currently, we're just using SQSQ. And it's also got error handling built into it, as well as all of the wonderful AWS CloudWatch metrics that look after your services. So a lot of the things, when you transition from developing like your own Python code into an AWS managed service, yes, a lot of the things are under the hood, so sometimes you kind of miss being able to tinker. But really, at the end of the day, we rather went with this service than wasting time managing infrastructure and integrations between everything ourselves. So it was a lot easier to update things. The last thing of this is the maker. Now, I mentioned that we were consuming data from on-premise Kafka clusters. And while we were developing this platform, we also needed to facilitate this data actually getting to the platform. So we developed a small little application that helped our data get from Kafka, be in the middle, and send it to the platform, and we called it the middleman. Really creative. So the objectives here was nice and simple. It was to consume data from Kafka clusters, guarantee the delivery of all the data, of course, considering low latency, redundancy, and visibility for monitoring. And the architecture, it looks a bit busy, but it's quite simple here. We've got the Kafka clusters. We've got a simple VPC with availability zones. We used ECS Fargate clusters to run a Python script that was consuming from the Kafka clusters. And then we simply sent it off to the GDP platform, which is, I don't know if you guys can see that, little GDP fella there. Now, for the considerations for this architecture, we want to make sure that it was low latency. Well, in regards to that, we have the availability, luckily, to use direct connect to get that data from on-premise into our application. As well as that, we were using VPC endpoints to make sure that we were traversing the AWS backbone where we could, make sure that we were keeping traffic not going external where possible. For redundancy, we've got the typical measures of the two availability zones. Within the ECS tasks, of course, making sure that if any of the tasks drop out, that it's able to consume from the Kafka clusters where it last consumed. So that was some nice coding that we got to do as well. And then lastly was the visibility. So visibility is really easy, of course, with all of the AWS monitoring, but on top of the application logs, we were able to easily gain insight into if the Kafka clusters were stopped producing data, if there were issues on that side, if there were issues within the ECS clusters actually processing or sending the data, and then, of course, how much data was being sent through to GDP. So between the middleman and GDP, we were able to kind of create a redundancy situation to make sure that what we were sending to the platform, we were also receiving. So this is like all really nice if we consider this plus the platform, but there are a few things that are missing when you have to, I suppose, present it back to the client. So far, we've got data going into Snowflake. We've got a route for the data to be consumed at low latency, and we've got simple methods for this data to be filtered or transformed. But some of the other considerations that we need to make is repeatability. How are we going to onboard potential new makers and takers? How are we going to do that easily? Scalability. What is going to happen if we increase data usage? If we get a new maker that produces so much more data, is that going to affect the rest of the application? And of course, observability. How do we know we're guaranteeing delivery? And how do we know that we're doing everything at low latency? So for repeatability, it's a good time to mention that all of this is done in a zero-touch environment. So no console access. It's all deployed through infrastructure as code via a pipeline that we have in Bitbucket currently. But that actually kind of gives it an advantage for us because it's all already in stacks. So you'll notice that the regular taker, that simplified architecture, and the fast taker are already in stacks. So that makes it the perfect opportunity for us to make this reusable. Each time we want to onboard a new maker or a taker, though, we don't want to go into the pipeline or the code base and replicate resources and all of that. It's tedious, and also we want to not be the blocker for the client. We also want to enable them to control who is onboarded onto the platform, not just ourselves. So considering all of this, we introduced the tenant management system. And really what this is just an API that enables a management user to be able to dynamically spin up a maker or a different taker. Not just that, but delete and update. And what we've got here is the tenant management API. We've got simple authorization happening with the Lambda function, retrieve secrets from Secrets Manager. If it's successful, it goes through to tenant management API. And then we've got all of the functions that it can choose from, and the Lambda will perform those actions. Any of those actions are logged against DynamoDB tables for logging table, user table, and tenant table. So tenant table is where we keep the information relating who owns what, which maker is consuming from, which taker is consuming from which maker, and such information. And then we've got step functions that are using the CloudFormation templates that we, CloudFormation stacks that we previously used to deploy them dynamically into the environment. And obviously this accepts specific parameters. So like they are able to say which data they want and what kind of filtering they want. So it allows that flexibility still, while we don't need to make any deployments. So considering all of that within the full architecture, it's looking pretty okay now. This centralized management with our tenant management API. Our tenant management API encourages centralized management because, like I mentioned with the DynamoDB tables, you've got visibility into who owns what. You can see what is happening. You can see who is accessing what data. You can see what is being filtered. So if any person needs to be audited or they need to cull down what kind of data is being accessed by who, they know where to look. The next thing is scalability. So we need to make sure that within the architecture, all of the makers and takers aren't affecting each other's resources. So that means separating the resources. By allowing each producer to have their own stream, and when a maker is onboarded and a Kinesis stream is created for them, they get to decide how big the stream needs to be, essentially. They provide metrics as to how much data they'll be sending, so they're responsible for creating their stream size. They can always go back later and update it, but that creates some responsibility and ownership onto them. Additionally, with the stacks, if you are consuming from one Kinesis stream, we've got the EFO, so that's not going to affect any of the consumer's performance. And then we right-size any shared resources. So you'll notice the enrichment function in the dead letter queue processor, making sure that concurrent executions, not that we've faced any issues with these particular shared resources, keeping an eye on them each time we're doing production deployments and just reviewing that frequently. And then, of course, transparency into usage. So that's what I was mentioning about each producer and each consumer being really conscious of what they're doing, how much data they're sending through, and being aware that they're able to change that to reduce costs as well. Next one is observability. So I mentioned that a lot of all of the cool services already produce a lot of their metrics. We use that heavily, of course, along with application logs from ECS and any of the transformer functions. We use that, and we create CloudWatch alarms that triggers pager duties, and that obviously sorts that out according to severities. The important part here is to make sure that we're not getting overloaded by all of our alarms. So we make sure to tie the alarms to key performance indicators, of course, according to our guaranteed delivery and our latency. Those are one of our two important ones. So making sure that those are configured accordingly. But how we actually monitor our most important ones, like latencies, is through benchmarking. With our fast taker, that's like our key one where we are really reliant on fantastic performance for the latency. We've got the opportunity to append metadata onto the records to say when it's been consumed from Kafka, and Kafka has a timestamp. When it's processed in the middleman, we can append a different timestamp. And each time it goes through each of these hops, we can append a timestamp, extrapolate that information when it arrives in its destination, and gather some awesome metrics. The only problem is that we don't want to do this to a team that already has like a latency critical application and be appending our metadata to their records. So that's why we've got a fast benchmarking stack, which takes a fast taker, but it's a little bit simplified, and it runs alongside a different consumer. So it's not affecting any production resources. We're just kind of sitting alongside and checking things out. So yes, it goes through the Eventbridge pipe. It goes through the dead letter queue. We've removed one dead letter queue. It's just to simplify it a little bit. And then the target is the benchmarking function that consumes it from dead letter queue and the Eventbridge pipe. That produces all of the logs and metrics that we need to send off to the CloudWatch dashboards. And from that, we get some really cool things. And a lot of the time, it's all really happy numbers. But I'll go through some of the dashboards that we've currently got. So this one, we get to see for all of the different data centers. So for this one, we've got 3 data centers at the bottom, what their total average latencies are. Obviously, average is a dodgy statistic depending what you're wanting, especially when we're considering our SLOs. So we've got, we can customize the dashboards, change it to see what we want. We've got the maximum end-to-end latencies. We've also got more specific dashboards according to the data centers, and you can see the jumps there. So we've got Veyron to Kafka, Kafka to middleman, Veyron's the data center, middleman to Kinesis, and then Kinesis to our benchmark function. And you can see that actually even before it gets to AWS, that's actually consuming a lot of the time there. So the latency is more focused around here, what we've got control over. We've also got, I suppose, more percentage metrics to see what percentage of data is within our target latency. So this one shows overall end-to-end from data center to the Lambda function. We're looking at this percent of data is less than 700 milliseconds compared to here, we're specifically looking at Kinesis to the benchmark function. We can see that this gray area here is roughly around 60%. So 60% of the data is under 200 milliseconds, which is pretty groovy. Some additional dashboards that we use, we've got the record counts, so we can see how much data is being pulled from the data center. These kind of metrics are mostly specific to our Snowflake route, because we luckily have the ability to, we've built the middleman, we've got the capacity to see these things, and it might not be visible for us for other producers of the platform. We also get to see from the middleman, how many records we're publishing to the platform. And then obviously a little bit more specific middleman metrics to see which partitions we are consuming from. If there's hot partitioning, if anything's happening there, we can contact perhaps the data center team and discuss and troubleshoot that way. And a lot of the time, the metrics that we collect are really useful because they might not have that much insight into what's happening there. Yeah, so overall, it's been a wild ride. And there's so much I could talk to you about, but hopefully that's provided a little bit of a taste into all of the services that we've used and some of the considerations that we've made so far. Thank you.
Any questions? Well, we got to make up 15 minutes to pizza, so I have some questions.
Why Snowflake?
Why Snowflake? Oh, that wasn't. Yeah, no, that wasn't our decision. No, they've got a big team that uses Snowflake to process a lot of the data even further, to produce reports and billing data and stuff like that. Yeah. Yeah. Yeah.
In Kafka, you can have several consumers reading again and again at their convenience. But once you put that into SQSQ, only one can consume it and delete, right? So essentially, this one-to-one communication. Is that correct? Because my initial understanding was that some other consumers can join later and use this data from this data platform.
Yeah, yeah.
But once it's processed and deleted from SQSQ, then no one can reach it out.
Yeah, no, very valid. So if another consumer wants to join the platform, then they don't have to consume from that same SQSQ. So what would happen is if you wanted to consume that data, an additional fast taker stack would be produced for you. Mm-hmm. And those two queues would be presented to you.
So it will start from the beginning?
No, it can start from this stream. So if you want to consume this data, your consumer stack can be created and consuming from this stream. If you were interested in other data from another stream, you could specify that stream. As a consumer, you can say what you want to be consuming.
Maximum retention in the stream lasts 24 hours?
Yes.
Like that.
Yes.
So no historical data from it?
No historical data. We did explore the opportunity of potentially doing some data storage in the platform and doing some really cool analytics, but that wasn't the scope of the project. But yeah, the fact that it doesn't have data storage, 24-hour retention, shows that a lot of the data, the consumers of the data aren't sometimes interested in that data if it's stale. So
they can have storage at their own site.
Exactly.
If they need.
Exactly. Yeah, yeah. So yeah, they consume it with their role. They do whatever they want with it. Yeah.
Cool. Thank you.
Yes.
What kind of latency difference are you getting between the regular taker and the fast taker?
So the regular taker, before we had the pipe, we had.
That was the Lambda-based version?
No, I actually didn't show the architecture, but we had a regular taker where the items go from the Firehose and get put into a bucket. And Snowflake has a different integration with AWS where it will have an SNS topic that gets loaded on that bucket. And that integration, we were seeing around 15 minutes. And then, of course, with SNS, you don't have guaranteed delivery of all of those notifications. So you could potentially be putting an object in the bucket, and they might not be getting notified on their side. With this new integration, it's actually relatively new. So we'll have to find out soon when we collaborate with the Snowflake team to see what latencies we're getting. Yeah.
Why did your client do this? Are they looking to get rid of their on-premise data center stuff, or what's the reason?
So the on-premise data center was, obviously not everyone was able to access the on-premise data, but a lot of people, a lot of teams were interested in accessing that data. So I suppose to reduce a lot of repeated architecture of a bunch of different teams having to access that data and them having to manage consuming and doing all of that, they wanted to rather extrapolate all of that efforts from all of those teams and just centralize it in one place.
And will that on-prem team start using this now? Have you successfully managed to get them from drinking from the capital queue?
Well, Yeah, maybe. That's we don't work directly with the on-premise team. So that could be cool. Okay.
Another one. So there's a real periodization of the data. I don't know if that's the correct term.
Yeah.
Like the latencies kind of peak every day. Is that just the nature of the data? It's nothing related to the capacity of the system?
Yeah, no, nothing's wrong here. I swear. I swear. Yeah, no, that's normal.
You don't like alert on that kind of thing because it looks like there's just less messages, happening, and then the latency was dropping a little bit.
So yeah, this one's completely with records. If we have a look,
That one there, but if you go back one,
this one.
graph there, you can see dip every kind of 12 hours, I think it is.
Yeah. So at least with our SLOs, that's why we want to make sure that we don't get alerted all of the time with these dips, because you can kind of very rarely, if you squint, you can see that these dips are affected, and it affects the latencies of a lot of the records. But those high latency records, they stay reasonably the same. So if we say 90% of our data needs to be arriving at the destination under 1 second, this will still allow us to meet that.
Are you using direct connect between data center and AWS to reduce network latency?
Yes.
Were there any other choices that you considered other than Eventbridge pipes? And did you have any troubles or difficulties implementing Eventbridge pipes, or was that an obvious choice?
No, we really wanted, I think a lot of the developers in the team are really keen to make Lambda work, just because they can code. We had a bit of, I suppose, concerns around using Eventbridge because we wanted to make sure that the latencies were going to be good. That was our main concern. We did a lot of testing with the benchmarking functions, and we did open up a lot of AWS support cases that were really helpful in solving that. And they did have a few investigations, especially because we're triggering that transform Lambda function. We want to make sure that that latency is also not going to be a lot. So they did help us reduce the latency there to make us happy with our decision.
And does the batching come into it there? Like, did you have to tweak those sort of parameters, or?
Batching.
I think it pulls in batches, right?
Yeah, I'm trying to remember.
That's right.
You're looking at me blank. Leaving me dry.
Is there any other, big lessons learned that you had? Something you wouldn't do again or should avoid?
I think something important is that while latency is so critical, it's really hard to manage that with costs. Because we've had a few teams join or inquire about it, and everyone is like, oh, sub-second, let's do it. But deploying Eventbridge and consuming such volumes of data, it's going to be expensive. And then also validating the performance, identifying if you want to validate the performance the whole time or just during periods, because that just doubles the costs as well. So yeah, it's a mission to balance that.
I have a question.
Yeah.
With the Lambda functions, the transformers, did you guys ever run into any throttle limits where there are too many Lambdas running?
I'm going through my history in my brain now. Specifically for the transformer, I think so. But we've tried to make sure that we right-size those Lambda functions between the environment for the environment before we take on a lot of load. So making sure that we increase any limits for Lambda that we can.
That would have to be through AWS support, right?
Yes. Yeah.
How many records per second do you process?
About 7,000. So yeah, it's all going through in batches. So yeah, we're writing to the stream in batches, and then that's getting processed throughout the entire flow.
Have you had any challenges with timeouts?
No, I don't believe so.
No worries.
What's next?
What's next? We'd really like to, well, actually, there is potential for us working on creating different producers. Because obviously everyone wants to consume data and they might not have the capacity to send data to the platform. So designing applications, slightly tweaking potentially the middleman to send more data to the platform, but a different use case. And then of course, we want to onboard more fast takers. One of the awesome things is with the tenant management as well, you have that visibility, but you can also add tags. And the tags help us to make all of the consumers and producers of the platform conscious of their costs. So if I'm creating a stream and I've said I'm going to use 55 shards worth of data, and my name's on it, I can be held accountable if I don't use it at the end of the day. And same with all of the teams that are consuming the data. So then that creates really beautiful billing dashboards or billing reports to see how much is being spent for each team.
I have a couple of questions here.
Yeah.
Did you have any reserve concurrency? That's the first question. The second question is, was it Python or Rust?
Was it Python or?
Rust, please. Runtime?
Python or Rust?
Oh, it was Python.
That goes to the last presentation there. Okay. Did you have any managed reserve concurrency for your lambdas, or the default concurrency was enough?
No, I think we increased our concurrency. I can't tell you what we increased it to though. Sorry. Yes.
Obviously, the terminology tenant management. This is like for one customer. I'm just wondering if you're enforcing any sort of security boundaries as part of that, or if it was all deployed in the one account. Just interested in that part, if that's a consideration, or if it's kind of open because it's a single customer solution.
Okay, yeah. So this is deployed in the organization of the customer. So they've got multiple accounts, and it's deployed within. Well, we have a sandbox, dev, test, prod, and so this is deployed in. The tenant management is deployed in those specific project accounts. So it's project specific where this is deployed, and then the people who have access to the tenant management is the product owners. So they've got access to those keys, and they can use that. And we've provided access to documentation and everything like that. If that answers the question.
Did you have a chance to suggest this solution to other customers?
We have tried so far. We have had the opportunity with a very similar use case of them needing to consume data from a data center and make it available to different teams. And I think the really big selling point here was that you might not need a specific regular taker or a fast taker or make it go to Snowflake. It's if you want to send it to a different application in AWS, it's okay. It's just putting in that template and then putting it in the platform. So it's I suppose the concepts of it, and then it's really adaptable to the different use cases. So yeah.
Any specific service limits that you had to adjust to the platform?
Which service limits?
There's definitely headaches.
I can't remember off of the top of my head. We're actually busy reviewing service limits a ticket in our upcoming sprint again. Yeah, sorry, I can't think now.
Lambda concurrency would be one.
Yeah, apart from Lambda concurrency.
You mentioned as a part of the tenant management stuff, you can push updates as well. How do you push updates but also maintain your service levels?
Yeah, so that's something that is quite tricky, right? Because you've deployed these stacks up into the platform, and and that's not part of your pipeline anymore. So because we don't want to have to make these code changes, we've got now these stacks that we'll have to perform updates on through CLI currently within the pipeline or run additional scripts. So that is another feature that would be really awesome once it becomes, I suppose, more applicable, or we've got more than 2 use cases to perform these updates. But there is also always the opportunity, because we've got Kinesis, is to create a new one. And then once that's switched over, once the data is flowing through the new update, whatever it may be, switch off the old one.
Any more? Did really well at soaking up 15 minutes. Sorry.
I told you no questions.
Awesome. Well, pizza's meant to be at 7. It's not here yet, but there is beer outside, so that works too. So what we'll do, we'll go outside. Pizza should stand outside. Thank you, Maxime. Really, really great.
As a bit of a qualifier, this is my first time presenting, and I am feeling very nervous, so please be gentle with me. Oops, I was afraid that was going to happen. Oops. And there we go. Okay, so I think the topic deserves a bit of an introduction, because it's kind of weird. I started learning Rust about a year ago, because I thought that I would become a better developer if I understood a bit more about how low-level programming worked. So I was thinking, do I learn C, C++? They're kind of old languages, so I thought I'd take a punt and give Rust a go. And I had thought all along that I would be working on low-level kinds of things. So I was really surprised when at reInvent last year there was an awesome presentation about this exact topic. Because when I think of Lambdas, I don't think of C, C++, or Rust. I think around 80% of Lambdas are written in either Python or TypeScript. So it seems to generally be the domain of interpreted languages. So why Rust then? That's a good question, and that's why we're here. So a bit of an intro to begin with. So all of this is available online. I'm not going to go into it too much. Rust is pretty new. It was created as a side project in 2006. Mozilla took it over in 2009. Version 1 eventually got released in 2015. 2020, the Rust Foundation was set up, and AWS was the founding member. Soon after, most of the other big tech companies joined the team. And as it stands today, all of the big FANG companies are applying in billions of dollars in investment and development for Rust. So I wonder why. Let's do a bit of a comparison before we delve into that. So Rust is a different animal from Python, and we'll come to that. So first of all, Python, as I think everyone will know, is interpreted. Rust, on the other hand, is compiled. When we say compiled, what we're talking about is the code is translated into machine code before it's executed. Unlike, say, Python, where you have an interpreter and it reads the code and executes it on the fly. Now, Rust is unlike some compiled languages. Let's take Java as an example. Java is a compiled language, but you still need a JVM to make it work. Rust doesn't require anything like that, in the same way as C. What's next? Concurrency is a really important point. As I think everyone knows, Python has the GIL. That limits us a hell of a lot. There are ways around this, but they almost all involve another language, whether it be C, C++, Rust, or CUDA. There has been talk that Python will eventually ditch the GIL, but I'm not seeing it happening anytime soon. The next thing is performance. Rust is blisteringly fast. It is one of 4 or 5 languages, I think, that's in the petaflop club. Obviously, you need some very specialized supercomputer type hardware to achieve those speeds, but it puts it in pretty rarefied air. Python, as much as I love Python, is not the fastest thing in the world. Error handling is another interesting thing. And this is one of those things that makes people either love it or hate it. Rust throws all of its errors at compile time. and your compiler will scream at you constantly. You will learn to hate it until eventually you learn to love it. Python, on the other hand, doesn't throw any errors until you press run. When you press run on a Rust program, after it's been compiled, you're not going to have any errors. That's all been checked for you. You can be guaranteed that it's going to work. Memory safety. This is one that we could probably do an entire presentation on its own about. I'm going to quote a couple of stats, and I hope they're right, but they're often tossed around. I believe that in general, around 70% of security vulnerabilities are related to memory. And that's one of the number one issues with your C's and your C++. The whole reason that the raison d'etre for Rust was to kill that problem. So it has a really interesting ownership system. I'll mangle it if I try and dive into it. Suffice to say that it's really interesting, and it's one of the things that makes it kind of hard. Python, on the other hand, has no such constraints. You can create lots of memory issues if you want. Oh no, my thing hasn't come up. Oh God.
Already visualizing.
Yeah, there was meant to be a lovely image there. No, that's all right. What was meant to show there was a shot of the Lambda console with the two things up there and the interpreter in the case of Python. In the case of Rust, it shows Amazon Linux because no JVM or interpreter is required. It runs straight off the Linux kernel. So that leads us back to the question I posed earlier. Why is AWS investing in Rust? Well, we talked about memory safety. That's a really big one. I think everyone in tech is concerned about security, and dealing with the memory safety issue is probably the number one issue. Performance, we've also touched on. It's blisteringly fast. One of the ones that I was really surprised about is the third and fourth point. Rust is incredibly resource efficient and incredibly cost efficient. And as a result of that, it's also very green. Reading an Amazon blog, which I've got a link to at the end of these notes, they estimate that if they were to move all of their systems across to Rust, it would reduce their energy consumption by 50%. I will have to take their word on it, but I believe them. Now, AWS is already using Rust and has been for quite a long time. What was the thing that Neil was talking about earlier on? Remind me, Gravitron? So the latest build of Gravitron is partly on Rust. All of these other services are also on Rust. Firecracker, BottleRocket, Greengrass, even Amazon Prime for watching your favorite videos. But it's the last two that are really the things that interest me today. The Lambda runtime and the AWS SDK for Rust. Surprisingly, given AWS's long involvement with the Rust Foundation, they only got around to releasing a Rust SDK at reInvent last year. It's been in beta for a long time. So it's pretty cool. And that's, I guess, why they started to promote it heavily. And if you do a little bit of Googling, you'll find a lot of people who are promoting the idea of Rust as an alternative to Python for making highly optimized Lambdas. Is that a fair comparison? When I posted this up on LinkedIn, I had a friend of mine come back to me and say, hey, this is apples and pears. Well, I'm going to say apples and oranges. And that's kind of a fair point. They are so different that I'm not sure it's necessarily a fair comparison, but I'm going to argue that it is. And the reason I think it is because AWS is specifically pitching it as a potential replacement for Python in this case. So it's fair to make this comparison. So the Rust sales pitch, when people are talking about using Rust instead of Python or TypeScript to write your Lambda function, they're hoping that it's going to make it faster, make it more resource efficient, make it cheaper, and to be honest, to make it more green. How your priorities will differ between users and organizations, but those are the things that is promising. Kind of sounds too good to be true. Or to me, it does anyway. So I can't resist the temptation to try it out and see if I can achieve the same thing. And that's what this is really about. This, unlike the other presentations, this is not a work project. This is just an experiment I did for fun. So I took a couple of different presentations. I dumbed them down so it was fit for my level. And I tried to replicate it and measure it. So the test, I went to a presentation at the Brisbane Serverless Meetup group a couple of months ago. And Ilya Carvalho made a really interesting presentation comparing EC2 to Lambda. And he used the K6 load testing method. I thought that was really cool. And so I took that idea and the other one from reInvent, and I kind of combined the two. Okay, let's look at some code. So I'm going to start with the Python one, because you're all probably pretty familiar with it. Now, this is a really simple script. All we're doing is creating a UUID. We're saving it as a text file in an S3 bucket, and we're creating a record in DynamoDB. There's nothing super complicated about it, and it's a pretty short script. I think it's a total of 40-something lines and around 800 characters. It's not a lot. Rust, by comparison, is a different beast. Wrong file, Michael. Let's look at the code. We'll come to that. Okay, so if we look at it, first thing you'll notice is that Rust is really verbose. We have nearly 4 times as many characters, nearly double the number of lines of code. There's a ton more code here. The reason that will generally be given to you is that it's because it gives you a whole lot more control, and that's true. But I think it's important to recognize that there is a lot of cost, and this is going to be the theme of it. Not the cost in dollar terms, but the cost in terms of developer time. My own personal experience has been that it takes me orders of magnitude longer to write the same code in Rust compared with Python. It's often said on the internet that for an experienced developer, it'll take you 6 months to become productive in Rust. I've been working on it for a year and I don't feel productive. I'm still learning. It's a bitch. So when we look through the thing, you're going to have a look. The syntax is hard. When I read Python, it seems kind of intuitive. You can kind of read it almost like English. When I read this, I have to scratch my head, almost read it character by character. That's just me. Other people have told me that no, it's all just part of the learning curve. Once you cross that threshold, you'll feel the same way as Python. I hope that's true. What I wanted to show you all down here is an example of what I was talking about with the errors. Now, I was going to compile for you, but it takes about 8 minutes, and I don't want to waste your time just watching the screen. But I deliberately ran some errors, and these are some of the errors that you'll get. So this is compiling fine, but by the time we get down to the bottom, we start to throw warnings. Now, these are just warnings, but unlike Python, you can't suppress warnings. No way. You must deal with them. It can be frustrating, but it's also very helpful. You'll notice that it gives you pointers to everywhere that the warnings occur. All you do is click it, it takes you there. I find it so much more helpful once you get used to it, compared with the Python errors. When you get a proper error rather than a warning, it gives you a really elaborate and complete explanation of what the cause of the error is and what the fix is. I like it a whole lot more than the Python one. That said, I've had nearly a year to get used to it constantly screaming at me, so my attitude has probably changed somewhat. Another thing that I want to point out that's a little bit different is cargo. Now, in Rust, they talk about crates. Crates are the same thing as libraries in Python. Whatever reason, they call them crates. You manage your crates using this cargo.toml file. And personally, I think it's a pretty neat way to handle it. I like it a whole lot more than requirements.txt. To be honest, I think requirements.txt should die. But anyway. I note that since cargo.toml came out, poetry has appeared in the Python scene, and it looks remarkably similar. If you look at a PyProject.toml, I can see a little bit of cross-pollination, and that's a good thing. To me, that's praise. So dependency management is kind of nice. I want to talk a little bit about the compile stuff. I should have asked, is anyone a Rust person in here? Or a C, C++ kind of person? Feel free to tell me when I'm wrong. Okay, so when you read the Rust book, they will tell you it's as simple as cargo build, which you can see in line 5 here. It's not quite that simple. This one is really important. Release means it's ready to go to production. When you say release, it gives you the tiniest possible binary. If you compile to debug, your binary is orders of magnitude larger. Unless you are literally debugging, do not compile to debug. The next thing that's important is this bit, the target. So Rust wants you to specify exactly what machine you're working on. If you're compiling to ARM, you need to specify ARM. In this case, I'm compiling to x86, which I think pretty much everyone is still. So you must be very specific. I have missed one step on here which I should have included, and that is the strip function. So after you've compiled, you have your binary. You can then run rust strip, whatever your binary's name is. And that will minimize the size of your binary. After that, it's pretty simple. You zip it in the same way you would a Python one. Now, the first tip that something is very different is the size of our zip file. This one, unlike PyCharm, is still in beta, so it doesn't tell us the size of the file, but it is 3 megabytes. The exact same piece of code, let me find my PyCharm. In PyCharm, is around about 30 megabytes, so 10 times larger. And you can see just by opening up our package, just how all the dependencies and just how messy it looks. Now look at main. Main is something like 32 megabytes. So it's 10 times larger. That immediately gives you a hint of why Rust performs differently. And now back to this thing. So I was trying really hard not to get into a coding session. It's such a temptation sometimes. Where am I here? Here we go. Et voila. Okay, so we've looked at some code. Let's move on. Hopefully all my... no, don't tell me all my pictures are fucked out. I really apologize. It seems that all my embedded... I'm trying MARP for the first time. Alan Blockley said to me, hey, don't forget about PowerPoint, try MARP. I love markup, so the idea of using MARP for presentations seemed really appealing. When I moved from my desktop to my laptop, I've obviously done something wrong. So my bad, I sincerely apologize. There were worse and pretty graphs, but I'll talk you through it. Now, to my sadness, I couldn't replicate the high performance that the guys from reInvent were showing. They were demonstrating improvements of 8 to 10 times across all of the important metrics, whether it was cost, speed, resource consumption, cold start performance, you name it, 8 to 10 times. That's pretty incredible, I think. So I had hopes of replicating that. I didn't manage to do it. I did get 3 to 4 times the improvement, and I think that's still significant. Now, this is where it's going to get embarrassing because all my charts are missing. So we'll flick that. But just this one did come through. So when we look at costs, and have a look at this one, Python generally is around about 360% slower and about 357% more expensive. Big mark against it. Latency. This actually, I'm sad this is not here because this is the one thing that really performed. The latency plot looks just spectacular. Python up here, Rust down here. It is so responsive, it's unbelievable. And this is going to keep going like that. Let's just move on to the experience. Okay, so we've shown that the performance is awesome. But that's not the end of the story. I think that when people focus purely on the dollars, they're missing out on the whole picture. And I've noticed that whether it's social media or whatever else, people tend to fall into 2 camps when they're talking about Rust. They're either part of the cult or they hate it. And there is a little bit of cultishness about Rust, I must say. I would like to present a slightly more balanced view. Rust does perform a whole lot better, but what it does is move all the cost from production to development. There is a dramatic increase in cost of development. Like I said, for me personally, I reckon I spend 4 to 5 times more to get the same thing up in Rust compared to Python. For most people, that's not acceptable. The next thing, as we touched on, is significantly more verbose. That's a challenge, and it throws a lot of errors during development. While I personally think that the excellent messages compensate somewhat, not everyone's going to agree with me. Now, onto the really fun stuff and interesting stuff. Rust is apparently very popular. If you look at Stack Overflow, they say that Rust has been the most popular language for the last 7 years or something like this. And yet there are so few Rust developers. Is there anyone in this room who writes Rust?
They're writing code.
Sorry?
They're writing code.
I'm sorry?
They're busy writing code.
You're probably right. You're probably right. You're probably right. So this one kind of surprises me a bit, and I don't entirely understand it. I believe it comes down to the difficulty of the learning curve.
Is it then just more people asking about Rust and stuff?
I think that could well be it. That could well be it. So I was looking on the Rust Foundation's website, and they published a really interesting statistic. They say, out of all the people who start learning Rust, 55% drop off because it's too hard. Now, think about this. They're asking people who've already given up to respond to a survey. Do you think that that statistic is accurate? I would suggest it's undercooked. So
about Rust developers, I know quite a lot. A lot of those Rust developers are often system developers. They'll be in Linux kernel.
Yeah.
I like to say Linux conf.
Yes.
Or you'll meet a lot of Rust conf developers there, but they're not in the cloud space that we're in.
And do you think that's because they're used to that way of thinking? And
They
that,
come from C++, a lot of those guys as well, C and C++, so it's an easy progression for them.
yeah, an easier transition for them. Whereas
Coming from Python,
it's a shock.
a lot of people might go to Go or something like that instead.
Yes.
They want to go to a compiled language, not to Rust, because that is
Challenging.
I'm a C++ developer, and I find it hard. So.
I'm glad you said that. It makes me feel a little better. Some of this I've repeated, and I apologise. I'm not really good at reading notes. I tend to just talk for free. Anyway, so from my own perspective, I think Rust moves the cost of the development phase. It puts all the pressure off the accountants and onto the devs. Is that worth it? That's going to depend on the team and the organisation. But it's not the kind of binary case that it's often presented as. It's not an if-or thing. And I'm going to get ahead of myself again. Slow down, Michael. So when to use Python? Everyone knows we can build things really quickly in Python, and it's kind of the obvious choice when you're building prototypes. It's ubiquitous in data engineering, data science, machine learning, cloud, you name it. It's kind of the lingua franca, right? You're not going to have any problems finding developers who are competent with Python. And that's really important, right? Because I think it was Guido who said that code gets read 10 times more than it gets written. So it's kind of important that what you're writing is accessible to not only your peers, but the people who come after you. I think that's a genuine risk with Rust. And it's something to consider. We need to consider the whole life cycle of the product. So for me, I believe that if something needs to be understood and maintained by a lot of devs, then Python's the obvious choice. Everything has a Python SDK and an API. Rust, not so much. It's not as mature. It is growing and it is improving, but there's so many things that you just know that they're there in Python. You look, and unless you build it yourself in Rust, it's just not there.
How do you find, finding examples and things like that, like when you get stuck on something, how good is the support?
Surprisingly good, surprisingly good. And again, I hear mixed reviews, but from my own experience, as long as you're humble and you've made an effort, you're not just asking somebody to give you the answer, people are pretty helpful. If you've obviously not even tried, people tend to piss off.
No, I'm thinking more like,
Sorry.
So there's lots of examples
Yes.
of how to do things with actual code for Python, right?
Not much.
And you don't have much of that.
Much less, much less. So when I was learning Python, I would have trolled Stack Exchange a ton, and I would have been able to find examples, or tutorials, YouTube, whatever. I really struggle to do that with Rust.
So you're like routinely trawling through the gists, being like, what did you see? What did you see? That's like a routinely feel for you?
Well, more routine than I'd like. But to be honest, of recent times, GPT has been a game changer. And it's made life a hell of a lot easier. There are issues with it because it will want to think in certain patterns, and those patterns are often not consistent with idiomatic Rust. So you've got to kind of take whatever GPT says with a large grain of salt. Yeah. But it helps. Yes, sir.
Something that might be helpful is Codecademy is a subscription-based thing to learn different stuff.
Yes.
They've actually got
They do.
a Rust.
They do.
Course for that.
A number of those platforms, Udemy, Codecademy, whatever, have more and more courses. When I first looked at it about a year ago, most of them were basically people just presenting the Rust book. So the Rust Foundation put out this thing called the Rust book, and that's meant to be the canonical reference for the language. And that's great, but once you reach the end of it, what next? I'm hoping and I'm seeing that more and more content is being developed to take it to the next level. And I think that'll continue, particularly given that there's so much investment in it from the big tech guys. At least
the thing with Codecademy, what's really good is that you actually get to write the code and actually see the results at the end of it, and so you're actually understanding what's going on, and then it gives you tips on
which is super important. Yeah.
And let's try that again and that sort of thing.
You need that feedback and that interaction.
Yeah.
And at the beginning, I have to say that's the thing I missed the most. If you've got a mate who codes Python, it's really great to talk through how to solve a problem. If you don't know anyone else who codes in Rust, you feel a little lonely. So that kind of feedback is really good. What you can't go past is I've moved on to why I went to use Rust. So you can build fantastic tooling with Rust. It just takes a ton more time. And when you want absolute maximum performance, maximum stability, and maximum safety, I honestly think you should consider Rust. It's a clear alternative to C++ and C. Not to say that we're dismissing C++, but it's an alternative that should be considered. I had someone say to me just the other day that, Michael, you're totally wrong. Modern C++ is memory safe. I don't know enough to disagree with him. I'll take him at his word. But it's nice to have alternatives, right? I had always imagined it being something purely for infrastructure and systems. Now, this is what I wanted to get to, the compromise solution. It's not necessary to write your entire code base. In fact, I think it would be nuts to attempt it. If you already have a code base that's predominantly written in Python or TypeScript or whatever, the best thing you could do in order to improve your performance would be to profile your code base and identify those points that are causing performance issues, your bottlenecks. Write those bits in Rust. When you do that, there are two wonderful crates called Maturin and Pyo3 that will compile it into a Python library. And then you just import it like any other Python library. If you've come across Polars, which is a modern alternative to Pandas, apparently, Polars is exactly that. It's all written in Rust. They just compiled it so you can import it in Python. Same thing with Hugging Face fast tokenizers, if anyone's nuts about NLP. Hugging Face have been rewriting a lot of their tokenizers using Rust so that the tokenizing process is a lot faster than it used to be. So I would advocate that this is a much more practical solution for most people. Identify those areas that are causing you bottlenecks, that are causing you pain, and just deal with those ones. You get most of the benefits anyway. I didn't try this experiment, but if you get the chance to watch the reInvent presentation, he does do an excellent presentation on this very topic. And based on his numbers, you're getting 50 to 70% of the benefits across all of those metrics we mentioned previously. Now, we mentioned Go. Alan asked me about this when I was talking to him about the topic. I scratched my head at the time and I thought, yeah, I don't know the answer to that. I'm going to have to come back to you. So I did a little bit of reading. And I think it comes back to the philosophy and then how they've implemented the philosophy. If I understand correctly, and I know nothing about Go, Go's mission is to try and get rid of complexity, make things simple, make it easy to understand. Rust doesn't even attempt to do that. It sacrifices ease of use now, and it asks you to argue with the compiler. It asks you to spend more time researching your solution, and in exchange, you can write a code base that's robust and still kicks ass in 5 years' time. So it's a horses for courses thing, I think. Funnily enough, and I didn't realize this until I was looking it up, the logos give it away. If you look at the Go logo, it's a nice, round, soft-looking character, very approachable, very friendly. What's Rust logo? Spiky crab. Says it all. So conclusions. Personally, I like Rust in a masochistic kind of way, and I'm certainly going to continue learning it and building projects with it. But unlike what a lot of commentators say, I do not see it as a replacement for Python. I see it as a complement to Python. I have this idea in my head that I've yet to prove: develop in Python, deploy in Rust. And the next cab off the rank in terms of personal experiments is to try and build a complete ML pipeline in Rust, which will include serverless inference and edge inference, which are both notoriously difficult to achieve with Python. So I'm going to be curious to see if I can pull that one off. Now we wrap it up, I just want to say a big thanks to Alan Blockley, who unfortunately is not here, but he helped me a hell of a lot. Also a big thanks to Ilya from the serverless group. He provided a lot of inspiration and help as well. I'll share all of this, and you please feel free to look up all of these references. There's a ton of interesting reading if you're into this kind of thing. And that's about it. So thank you all very much.
Any more questions?
Please.
All right, okay.
So,
I'm going to make a comment. I always tell people to ask questions at meetup, but I just wanted to comment on the Rust angle. One
Sure.
of the things that people don't realise with Rust as well is it's come, especially from the Linux kernel perspective, you'll see C++ often developed by single developers. Some of them are actually almost dying, so old. And so there's a lot of legacy code in the Linux kernel, which will be through AWS Linux, things like that. And people are sort of genuinely worried about that maintenance of that, the cybersecurity, but also who's going to take it on. So some of these things are getting rewritten as Rust because people might be able to actually be able to grok that easier than these guys.
Linus
so they've come at it from that angle, but I guess there's other people who've come at it from the other side, which is what you're talking about. But there's a real, it is creating a place there in the cyberspace, allowing this quite complicated code. I was originally a C developer, had hash if def. Like scares the cat people, right? Removing all of that pre-compilation stuff is like a huge win. So that's and one final plug for my friend Tim McNamara. He's written Rust in Action. He's over in New Zealand, I think, at the moment.
Rust in Action.
He's a really good guy, a really great really great Rust contributor.
if you don't mind, I might hit you up for his contact details after this.
He has a YouTube channel as well.
Sweet.
He's a great guy.
To add to what you just said, I know Linus Torvalds was in the media just recently talking about the fact that there are more and more components of the Linux kernel being rewritten in Rust. So it is obviously pretty serious. And honestly, that's actually the angle I expected to be taking. And the reason I said at the beginning is I thought this is kind of a weird presentation is that, you don't associate these languages with this kind of thing. It's a weird angle. But hey, if AWS is promoting it, it's worth looking at. Yes, sir.
Fun fact about Tim, I second that recommendation. So he was at AWS helping rewrite parts of S3.
Yeah, right.
So the benefits you were talking about, he can give you the insight.
I must meet him. Anyone else? Yes, sir.
Working at a startup, how do you justify spending 4 to 5 times?
No, I don't. No, this is purely a home thing.
You don't know when your next client's coming.
And like I said, I think you've got to be very cautious about when you choose to use this. I haven't used it at all at work. It's purely a personal project. Right. I kind of felt like if I understood more about how the Linux kernel and other stuff that's under the hood worked, I might become a better developer. Whether that's true or not remains to be seen. But based on my experiences, I wouldn't dare to use it at work right now. I'm just not good enough.
So you say you wouldn't write a sow against company saying, hey, can you write me this thing in Rust? You can say, no, because you can't scope it.
No, if they come to me and they have that specific request and there's no other way, then I can be persuaded. But I would be really cautious. I'd be really cautious.
What's your multiplier? What's your risk factor?
Yeah, exactly. It's the risk factor, right?
Yeah.
It's the risk factor. And I think that's the thing that everyone misses when they're talking about this topic, about the risk factor. If you're trying to rewrite a large code base in a language that's highly challenging, you introduce a ton of risk. Yes, sir?
Did you try writing your benchmark in Go?
No, I didn't. I would like to.
What I'm curious about is if you might see, that whole 80-20 thing, you might see 80% of your benefit for about 20% of the cost. By comparison, because obviously we talk about Rust as a systems language.
Yes, correct.
Which I think is probably fairly accurate.
Yes. I think you're probably right. I haven't tried it yet.
I'm a terrible developer and I can
Go is much more idiomatic.
Yes.
There's kind of one way to do everything, which is why I quite like it.
Yeah,
I must say.
but
I wrote Python too.
Hmm.
I totally agree with you. You do the thing that's easy sometimes. And
Go is on my list of things to learn, but I wish I could learn faster.
I think if you looked at an example example of what you did for your benchmark, for example, have that knocked out in less than an hour.
You're probably right.
It's pretty straightforward. But one other thing to point out is I think Windows also uses effectively two languages, C and Rust.
Yes. Yes, it's becoming more and more common. Now that's an awesome question and definitely one worth digging into. The question in my mind always is how long do you spend trying to master a particular language before you dilute your efforts with adding another new one? I don't know.
It can be interesting for a comparison.
Yeah, totally.
As opposed to, for example, you can learn Go as a language relatively quickly. It's very simple.
Yeah?
But I'd just be curious to see
me too.
the time effort involved compared to the performance improvement.
Yeah, me too. And I actually do need to make one qualifier about this particular experiment. It bucked the trend in terms of the amount of work required. Came together surprisingly easy and quickly compared to everything else I've tried to do in Rust. I reckon this is the only case where the development time is roughly equivalent to Python for me. Everything else 4 to 5 times more. That surprised me a lot. And it's certainly not because I've become a better Rust developer. Any other questions? Oh, yes, sir.
Have you faced any issues like using Rust and Python in the same code base? And does that add to the developer cost that you mentioned?
No. As long as, when I say that, I'm following when I try to incorporate Rust into my projects, I'm following that pattern of compiling to a Python library using Maturin and Pyo3. And doing that, no issues. It's almost seamless. You wouldn't know that it was written in another language. That's one of the reasons I feel very confident in recommending that as a good way forward.
Are you using a particular build tool around your Rust for the serverless stuff? I know like some people use serverless and this other thing, or are you just literally writing the code and uploading it in the console?
Right now I'm just writing the code and plugging it in the console. Yeah. I've been reading about some of these other tools, but I haven't put my toe in the water just yet. I figure one thing at a time.
If you want to do, if you want to actually have pipelines and do builds and deploys and that's where you start.
Yes,
That kind of thing.
exactly.
I don't know the answer to that. I don't know the response.
It's a good thing to learn about. I have a question for you, if you don't mind. It seems to me that C++ is very object-oriented. Rust, on the other hand, doesn't seem to lend itself to OOP at all, particularly because of this ownership and memory management problem. It seems to lend itself really to a functional style.
Language, and also C++ is entirely OO in some places as well, right?
Yeah.
I don't code modern C++, actually hate it. I'm from like the 1990s C++. Yeah, I don't know the answer to that. Same with Go. Go isn't like an OO language either. It's sort of component-based. I don't know what they call it. Composition, that's the one, yeah. Maybe Rust is similar, I don't know.
Yeah. Those differences are, I guess, for me, one of the reasons why I found it so difficult to learn, because all the things that you've learned around the concepts with Python and TypeScript are out the window. Don't apply. I felt like I was starting from scratch. It's interesting to hear that people who come from a more systems language kind of background probably have an easier time of it. But that shouldn't be surprising.
Yeah, it really depends. What I'm trying to do some data science thing, I just use Python.
Oh, absolutely. Absolutely.
But if I'm writing something to be like a system tool,
Yes.
and the command line for managing files or something, I might put that in.
For me, the only time I would consider using Rust would be for well, this is not the only time, but in general, I would consider Rust for things that are security critical, cannot crash under any circumstances, and need to be blazingly fast, and where development time and cost is no object.
And well-defined.
Yes, well defined.
Is there a Rust group in Brisbane?
Not that I'm aware of.
Yeah, that's the comment I was going to make. It's much more fun when you're with friends, right, learning languages. So you're trying to see if you can find some other Rust devs, same with Go. And I've got Go devs in my team, so that's why we've done Go. Because it's not just me. No one else in my team likes Rust at the moment. So. But I have one guy who really likes Go, so I ended up doing Go. So for you, maybe find some friends.
I would love to find some friends. The point you made about well-defined, I think is worth touching on. Sorry, if you guys don't mind. Well-defined, that's a really solid point. I found that it's really hard for me to start with a blank sheet of paper. If I already have a working Python program, concept's clearly defined, it's already working, it's so much easier for me to then move it into Rust. Starting with a blank sheet, not so good. And I think that comes back to clear definition. In order to get the functioning Python program in the first place, it needs to be clearly defined, I think. Oh, one more. Yes, sir.
Given how much time we spend debugging Python, right, all the way through the interpreter, years on end, although Rust puts all that time up front, when we think about the life cycling about Python, would we actually be in front if you took the long-term view rather than the 18-month perspective on our Python code?
That's an awesome question. I would love to see some numbers back it up. The people who are very Rust culty would say, yes, absolutely. You're 100% on the money. The people who are not so culty, I don't know. But I think to answer the question, we need data. That would also be a cool experiment to run. Awesome. I get the feeling I need to shut up.
All right. Thanks, Michael. That was
my pleasure.
I don't have music to play, so I can't walk you off or anything like that. I'd love to keep going, but people have bedtimes, so we'll keep going. So I will be extremely quick. So of course, thank you to the people and organizations that help make this happen. ADA 11 ThoughtWorks and AWS. That's how we get pizza and nice venues and beer and all of that. So that's all very helpful. We've had three really great speakers today. We're always looking for speakers as well. So feel free to scan the QR code, give you a little bit of form. Even if you don't know what you want to talk about, but you just want to talk about, you can put your name up and we'll make you talk about something. Next month is a bit of a special month. So it's a Gen AI themed thing because we've definitely got not enough Gen AI. But it's going to be a bit of a longer one. We're going to start a little bit earlier and end a little bit later, I think. But this is going to have multiple talks. I think it's 4 or 5 different talks we're going through, multiple speakers, special guests, and all of that. So we're cramming it all in. There's prizes and a whole bunch of other stuff as well. So please come along. That QR code's for the actual event itself, so you can RSVP and off you go. So that will be next month. So looking forward to seeing everyone there. And in September, I'm pretty sure I said last month we'd have the thing up. We still don't have it up. But that will, game day, if you don't know what a game day is, essentially it's a team-based competition. So this is, we'll have tables out, laptops out, competing, building gamified microservices and a bunch of stuff, and everyone gets to compete against each other. So it's a whole bunch of fun. AWS foots the bill for your account, so we're all good on that. But picture this room, 2 more rooms down, teams of 5, I think it is. So if you have a team, feel free. We'll be able to bring it all through. And if you're really competitive, you'll like this a lot. This is the same things they run at reInvent and Summit and all of that as well. This will actually be the first user group to run one, I think, ever in Australia. So definitely in Brisbane. I'll claim that one. Cool. We have a YouTube channel. This went live last month from the recordings from last month. You'll now get to see the recording of tonight, so you can rewatch it again and argue about Rust some more.
Go to those comments.
Yeah, that's it. So we're going to keep that going. We're going to also put in things like extra content and videos and stuff that we have of other people around and that kind of thing. I think I meant to say like and subscribe or something like that. I think that's how it works. So we'll do that. We have a Slack as well. It's how you can annoy people like me if you really want to. But also we post up things around the events, people asking questions for help on stuff and all of that. Maybe you can find a Rust friend. And there's, I don't know if there's any more Rust people in there, but we'll find out. And of course, feedback's important. People like to know if we're doing good. I'll give you actually a thing. Feedback's really important. We get about 1 a month. And I see you all taking photos of it, but we get about 1. So we're obviously really, really good that we just don't need feedback. So I think that's all right. But yeah, feedback's appreciated. Of course, 5s all down the side is how I keep a job. So we'll keep going that way. Awesome. That is it. Thank you very much. Appreciate your coming out. And look forward to seeing you at the Gen AI event next month. Have a good one. Safe travels home.